Hey guys, today we are going to look at operations with algebraic vectors in R2. So to begin with, you will remember, hopefully, that there are two different ways that we can write algebraic vectors. The first one is that we will write it as, so we can write it in scalar components. So in other words, you write it like this, where we just break down the components and write it as coordinates like that. Alternatively, we can use unit vectors. So we could say, we take that Vx value and we multiply it by the unit vector I plus the Vy value times the unit vector j. Okay. Furthermore, the magnitude of the vector, so the magnitude is written as the square root of Vx squared plus Vy squared. Okay. So we're going to take a look at the vector A, which is negative 3i plus 4j. First thing we're going to do is we're going to write it in component form. So we just say, this is fairly straightforward. So the x value is just going to be negative 3 because that's what we're multiplying the I by. And then we're multiplying the j by 4. So the y value is 4. Okay. If we go to find the magnitude of this, so we've got A, it's just going to be the square root of negative 3 squared plus 4 squared. Okay, and that's just going to give you a 5. You'll notice that it's always a positive 5. It is worth noting the magnitude will always be a positive value because having a negative magnitude implies direction, which when we're dealing with magnitude we should be ignoring the direction. That should come by itself. Okay, so we've got a little investigation here. So what I would like you to do is I'd like you to pause the video and complete the investigation and come back. Okay? All right. So let's summarize what hopefully you came up with in that investigation. So we're going to look at addition of vectors in R2. So the sum of two 2D algebraic vectors, which we've got A and B here, would be given by. So, in other words, I want to know what A plus B is. Okay, and so all you have to do for this is you just take the two components. You take the x component of A and you add it to the B component, the x component of B, okay? And then we do that with the y's. So we've got the x component of the y component of A plus the y component of B. And that will give us our vector. Okay? Alternatively, we could of course write this as ax plus bx times I. Whoops, I'm not sure hold on. I added a bracket I didn't need. Okay. So I would have that plus the ay plus by times the j vector. Okay? So that's all you do. You're just taking the two x components and you're adding them, and you take the two y components and you add them. So if I have the sum of the vectors 3i minus 5j, and b, which is negative 2, 7. Notice this is missing this. That should have that. I've just given it to you in two different notations, but it's fairly straightforward. So maybe we'll start by saying that a could be written as 3, negative 5. Okay, so that we can say a plus b is equal to 3 minus 2, and then we've got negative 5 plus 7. Okay, which gives us 1, 2. All right, and of course, if you wanted to write that using unit vectors, it would just be I plus 2j. All right, and there you go. So that's addition. So let's flip over. I don't know if I flipped. There we go. All right. Flip over, and we're going to look at subtraction. And subtraction is, not surprisingly, pretty much the same thing. So what we're going to do is we're going to say A minus B is just equal to the x component of A minus the x component of B and the y component of A minus the y component of B. Okay. We could, of course, then write this as ax minus bx times I plus, oh, yeah, no, that's right, sorry. Yeah, a minus b times j. All right, fairly straightforward. Now, it is worth noting that if I wanted to do b minus a, it is not the same thing, because of course subtraction is different if you do it in a different order. So you would be left with bx minus ax, by minus ay, which will be the same thing except with the opposite sign, but it is different, so it's worth noting that that is the case. Okay. So if I want to find vector d here, which I'm defining as a minus b, and we do have the same vectors we did in the last one, d is just going to be 3 plus 2 this time, and then we will have minus 5 minus 7, which is 5 negative 12. Okay, and there we go. So, multiplication by a scalar, and we'll call it, so we've got vector A here, and we're going to multiply by scalar m. And the rule, fairly straightforward, is just that m times a, we just take those components of a and we multiply them by m. So the x component times m and the y component times m. Which then, of course, we could write as this plus this. Okay, and there we go. So for our example here, we're just going to multiply the vector u by lambda, in which case we've got, so lambda u is equal to, so we're multiplying by the negative 2, so we'll have negative 2 times our x component, which was negative 1, and then we'll have negative 2 times 3. Okay, so we'll have 2, negative 6. There we go. I'm going to write this in using the unit vectors. In a test situation, if I do not specify which of these two forms to use, so if I don't say use this one and I don't say use this one, you only have to give one, okay? Unless it specifies, you only have to give one of those two answers. Either one is correct, and in this scenario, neither is better than the other. Okay, so let's just do mu times v here. So I'll do this one starting with 1/2 times 4i minus 1/2 times 2j. So this will give us 2i minus j, which is the same as 2 minus 1, like that. Okay, and there you go. So, example number 5, I want you to do on your own, and we'll take up at the beginning of the class. And so, until next time, go Sabres!